Now we will see the gear drives. As we have seen the belt drives, rope drives, and V-belt drives. So in these drives, one of the limitation of these drives, that is rope drives or the flat belt drive, is that they are not the positive drives and there is a slippage, and that's why these drives cannot be used for the precision power transmission or in the precision machinery. So only way to achieve the 100% power transmission, or we can say a positive drive, the only way is a gear drives, or we can say a tooth wheels. So these gear drives that we are going to see, it will have the biggest advantage that this can be called as a positive drive, or we can get a precise movement by using the gear drives. Now what is the concept behind these gear drives? So whatever the gear drives are being there, these gear drives are equivalent to two frictional wheels in contact with each other. Suppose we are having a two wheel A and wheel B. These are having a sufficient frictional surface on its periphery, and these two wheels are pressed against each other. So wheel A is pressed against wheel B. So when wheel A will rotate in, suppose in clockwise direction, obviously wheel B will also start rotating in anti-clockwise direction. So motion will be in opposite. So up to whenever this particular wheel A will rotate, it will rotate the wheel B up to when the tangential force offered by the wheel A do not exceed the frictional force F. So when this tangential force will be exceeded by the will exceed the frictional force, there will be the occurrence of the slippage, and these wheels wheel A will not be able to rotate wheel B if there is a slippage. Now in our gear drives, this slippage can be avoided by adding a projection on the peripheries of these wheels, and that we generally call as a teeth. So whatever the teeth on the wheel A will reside in the races on the wheel B, and vice versa. And this type of arrangement we are going to use in our gear drives, and for, we can say, for avoiding the slippage, and that's why this type of drives are called as a positive drives. Now we will see the classification of gears. According, these gears can be classified as follows. According to the position of axis of the shaft, these are classified as a parallel gear drives, intersecting and non-intersecting, and non-parallel. So we will see the parallel gear drives. These are gear drives are again called as a spur gear drives. So what we are having here, we are having two shafts which are parallel to each other, and these shafts are coplanar, and then uh, one two gears are mounted on it, and these are called as the spur gears. Whatever the gear teeth are there, that are parallel to the axis of the wheels, and these are called as a spur gears. But not necessary that whatever the teeth are being there, that should be always parallel to the axis of the gears, and sometimes these are inclined, and this type of arrangement is generally then called as a single helical gear drives, and it may be double helical gears, that is inclination, both side of inclination of the teeth will be there, and this is called as a double helical gear drives. The second type of arrangement or the classification is called as a when the shafts, two non-parallel or intersecting shafts, but these shafts are coplanar. These are the intersecting shafts or the non-parallel shaft, but these shafts are coplanar. For transmitting the power between these two types of shaft, whatever the arrangement is being used, that is called as a bevel gearing. Now the teeth of these bevel gears, these are again maybe parallel to the axis of the gears, or it may be inclined. If these are inclined, then it is called as a helical bevel gears. And the third type of arrangement, that is called as a non-intersecting and non-parallel. Non-intersecting and non-parallel, if we are having a shafts which are non-intersecting and non-parallel, that is a non-coplanar shafts, and these are being connected with the gear drives, then these are called as a skew bevel gears or spiral gears. And the arrangement is known as a skew bevel gearing or spiral gearing. This type of gearing also have a line contact and rotation which about the axis generate the two pitch surfaces known as a hyperboloids. Now, according to the peripheral velocity of the gear drive, these can be classified as a low velocity gear drives where the velocity is up to 3 meter per second. Then moderate or medium velocity gear drives where the velocity is from 3 meter per second to 15 meter per second, and high velocity gear drives where the velocity is more than 15 meter per second. Now, according to the type of gearing, whether the gears are being engaged externally or internally, these can be classified as external gearing. Here, whatever the gears are being there that are externally meshed, or the gears are or the teeth are externally on the both the wheels, and meshing occurs externally, and that's why it is called as a external gearing. But sometimes gears are meshed internally. Internally means meshing. In internal gearing, the gearing of the two shafts met internally with each other. The larger of these two wheels is called as an annular gear, while the smaller one is called as a pinion. While here in external gearing, the larger one is called as a spur gear, while the smaller one is called as a pinion. In the external gearing, the rotation of the two gears will be in the opposite direction. That is, if one is rotating in clockwise, another will rotate in anti-clockwise. But in internal gearing, if you can see, both the gears will rotate in the same direction. That is, if the annular gear is rotating in the counterclockwise direction, pinion will always rotate will also rotate in counterclockwise direction. Third type of arrangement, which is called as a rack and pinion. In this rack and pinion arrangement, one gear is a rotational while another is a straight line gear. While the gear which is a straight line gear, that is called as a rack, while the circular gear is called as a pinion. So from this we can very easily uh, assume very easily consider that this particular type of arrangement is used to convert the rotational motion into reciprocatory or translational motion, or translation into rotational motion. So this is the rack and pinion type of arrangement. This is generally used in our steering gear mechanism. According to the position of the teeth on the gear surface, as we have seen, this can be called as a straight, inclined and curved. It depends on how the teeth are being positioned on the gear surface. What are the advantage and disadvantage of the gear drives? Advantages are, it transmits exact velocity ratio. As we say, it can be used to transmit the precise movement, precise motion. Then second, it may be used to transmit larger power. It has a high efficiency, very high efficiency, near about 100% efficiency we can say. It has a reliable service, and it has a compact layout, very compact layout comparative to the belt drives. Then disadvantages, the manufacturing of the gear requires a special tools and equipments, and the error in cutting teeth may cause vibration and noise during operation. So we need to be very careful while manufacturing the gears for the gear. Now we will see various terminologies, various terms which are used in the gear drives. So just observe this diagram. We are having a section of the gear, and here there are the two tips, and then we will see various terms. The first and very important term which is generally used for defining gears are is a pitch circle and a pitch circle diameter. So whenever we design a gear drive, generally we design the gear drive, or the gears are classified by stating its pitch circle diameter and the pitch circle. So what is this pitch circle? As we have seen, gear is equivalent to the frictional wheel. So pitch circle is what? It is an imaginary circle which by pure rolling action would give the same motion as the actual gear. So instead of gear drive, if you are using a frictional discs, so whatever the motion given by this frictional disc, the same motion is being provided by the gear drive. So in pitch circle, it is nothing but it is an imaginary circle which by pure rolling action would give the same motion as the actual gear. So you can see this is called as a pitch circle. This is an imaginary circle and it would give the same motion as the actual gear. So if we replace the gear with the frictional disc, then the diameter of this frictional disc will be this pitch circle. That is what this pitch circle is. Then what is pitch circle diameter? Obviously it is the diameter of the pitch circle. From whatever the diameter of this pitch circle, that is called as the pitch circle diameter. The size of the gear is usually specified by the pitch circle diameter. It is also known as the pitch diameter. So whenever we will specify the gears, generally these gears are being defined or specified with the help of pitch circle diameter. So this concept is very important because this pitch circle diameter is generally used for defining the gears and for designing the gear drives. You can see over here, this is the pitch circle. Now the third term which we are going to see, that is called as a pitch point. Now what this pitch point is? It is a common point of contact between the two pitch circles. Now what is pitch circle? It is an imaginary circle. When the two gears engage with each other, so these two gears will have a two pitch circle. So if I consider this is a pitch circle of the first gear and this is the pitch circle of the second gear, so wherever these two pitch circles meet each other, this is called as a pitch point. This is called as pitch point. So pitch point is, it is a common point of contact between the two pitch circles. Now we will see pitch surface. What is pitch surface is? It is the surface of the rolling disc, imaginary disc which we are saying. It is the surface of the rolling disc which the machine gears have replaced at the pitch circles. If we take a cross section, of this and if we cut this, then whatever the surface we will get at this pitch circle, that is called as pitch surface. This is the pitch surface. Okay. Now pressure angle. This is again another very important term which is used for designing the gears, and that is called as a pressure angle or angle of obliquity. What this pressure angle is? It is the angle between the common normal to two gear tips at the point of contact, where the two gear tips meet each other. So that two gear tips will form a one point of contact, and the common normal to two gear tips at the point of contact and the common tangent at the pitch point. So once again we will see, it is the angle between the common normal to two gear teeth at the point of contact and the common tangent at the pitch point. Uh, it is usually denoted by phi, and the standard pressure angles for the gear drives are generally used as a 14.5 or 20 degrees. Now what is this? What it means? Actually, if you look, we are having a two gears meshing to each other. This is a pitch circle shown in the red, is a pitch circle for the one gear, and this is the shown in grid, this is a pitch circle for another gear. These two pitch circles meet at one point, and this is called as a pitch point. Now if I draw a common tangent to this two pitch circle, this is a common tangent. Okay, so this common tangent, and whatever these two teeth meet to each other, so to this two teeth profile, if I draw a normal means which makes a 90-degree angle, normal to this pitch, to this profile of these teeth, then whatever the angle between this common tangent and common normal, this is called as a pressure angle, and the value of it should be